Hey everybody, welcome to another episode of the Subnet Show. I'm Gabriel Cardona. Connor has the evening off tonight because he's going to be spending some time with his family. So it's just myself, and I'm joined by our very, very special guest, Michael Kaplan. Michael Kaplan is an engineer at Ava Labs, and he is the lead of the Bridge team. And there is just so much incredibly exciting stuff that recently happened with a huge release from his team. So we wanted to take this opportunity to bring him onto the show and get to know him a little bit better and hear about his vision. So how's it going, Michael? Thanks for joining us.
Hey, Gabriel. Thanks for having me. I'm doing pretty well. How are you?
I'm doing good. So I really do appreciate the time. It's Friday evening for Michael, so I just want to be super respectful of his time. And again, just express gratitude because I know you're incredibly busy. Everybody is. We just started what is known as Avalanche Rush. So there is just a absolute crazy amount of energy happening on our team and in our ecosystem, and tons of new projects onboarding. And out of my whole career, this is one of the most exciting and eventful times I've ever had. So again, I know you're incredibly busy. And so just wanted to bring you on and get a chance to kind of take a deep dive on your past, sort of your crypto journey and your crypto vision, and then just get a sense of where you see all this playing out. Definitely. So I think a good place to start would be give me a sense of, where did you grow up and kind of how did you get into computer science? And let's start at the very beginning.
Sure. Yeah. So I first got into CS when I took AP Computer Science in high school. Then kind of stumbled into CS as a major at Cornell. So a lot of our team has roots somewhere at Cornell, obviously because of Goon and Kevin. We're a bit diversified now, which is a good thing. I originally was intending to be a biological engineering major at Cornell, but found myself doing my CS homework. All engineering majors need to take a couple CS courses. And I found myself doing that homework to procrastinate other work.
Sure.
Like maybe I should just have only this work and that would be a happy life. So
you said you started in high school?
Yeah. My senior year of high school was my first time coding.
What language and what platform? How did that work?
So that was AP Computer Science. It was Java, JVM based, and then continued with Java first, as well as MATLAB, Python, C++ at Cornell. Actually, after Cornell, I was then at DraftKings for about a year and a half, and I was mostly developing in C# then, and now at Ava Labs back in C++ and Golang is the newest one. So kind of all over the place in terms of languages.
Yeah, well, it didn't seem like there was too much web stuff in there. I didn't hear JavaScript or anything like that, right?
No, mostly back end. Yeah.
So how did you in high school, what was your motivation for doing programming as a senior? How did that end up?
Yeah, so I always loved math and science, and it kind of was just a natural progression of that. I was lucky enough to go to a public school that offered AP Comp Sci, and it was a pretty small class at the time, like not many people took it, but I met with the teacher before enrolling, and it sounded like a cool opportunity. And it being my senior year is a little bit of kind of low stakes, just testing out the waters before going to college. But I mean, I remember the final month of that course, they just kind of had open-ended projects and they didn't really expect much. Of course, it's like most people's first programming course. And I was making a battleship program, which was like just printing out in ASCII on the screen, which nice. I remember staying up late at night, no, I got to get this to display perfectly. And then I built a computer to actually play against and to see how good I could get the computer to compete against me. So that was definitely the start of my interest there.
Did you have family, parents, brother, sister, anybody else who was in computer science?
Nope. I'm actually the only one. I have an older brother. He just graduated from law school. And my sister just got her PhD in psychology, actually.
Wow.
So all over the place. I'm the only one without an advanced degree.
Nice work to your parents. That sounds like they got some pretty successful kids. Okay, so that's pretty cool. So you were in high school and you got turned on to computer science pretty early based on your own passion. You started studying the JVM in high school. That's pretty intense. So that's nice. What were the sort of steps that led you from doing that to Cornell?
So Cornell was just kind of broadly appealing to me as a engineering school. Both of my parents went to Ithaca College.
Okay.
So I had been in Ithaca, loved the area, the gorges, the restaurants, the people. And I knew I wanted to go into engineering, but didn't really know what type of engineering I wanted to go into. And Cornell had a huge offering of different engineering majors. So it kind of felt like a win-win. No matter what I ended up finding as my passion, they would kind of have a strong program for me there.
And so you knew you wanted to be an engineer because you like math and science. Is that why?
Yeah, exactly.
Got it. And were your parents encouraging, or like were they kind of open-ended, do whatever you want? How did they feel about it?
They were just always supportive, very much do whatever you want to.
Sure.
They definitely were happy I ended up in Ithaca, though. Gave them a good excuse to come visit where they went to college multiple times a year. So
Nice.
They didn't push Cornell, but they were like, "Yeah, you should do that. That sounds good to us."
Got it. So, have you played around with any other JVM languages like Kotlin, or are you familiar with any other stuff?
A little bit of Scala, but not particularly.
What did you
I've
think of
mostly just
Scala?
used it for coursework. Since graduating, I haven't written a line of Java. So,
What did you think of Scala?
it's really good at specific tasks, and I think when you know what those specific tasks are and how to apply it, it's a perfect tool. I'm not super knowledgeable there myself, though, so I definitely don't leverage it too much nowadays.
Got it. Okay. So you ended up at Cornell. What was your first year at Cornell?
2014, the fall of 2014.
Okay.
That's when I started. Yeah. Then I graduated in 2018.
Okay, so you were there for 4 years. Got it. And what did you get a degree in?
Computer science.
Very cool, man. That's awesome. Congratulations. I know that was no small feat. I'm sure graduating from Cornell is challenging.
Yeah, it was definitely a challenging but rewarding 4 years, I'd say.
Do you is anybody on our team right now somebody you went to school with?
Yeah, so I knew of Stephen Buttolph and Dan Lane at Cornell. We weren't super close, but we definitely knew each other. We took a few of the same classes. Stephen and I actually were both in the blockchain course that Goon taught. That was spring of 2018, which was our the first time that we really met. And then when I came to interview at Ava Labs, he was there. I was like, "Oh, I remember you." And now he's, of course, the lead architect behind Avalanche Go, and so
absolute legend.
Very cool story.
Yeah. So I wonder. I ask this question often. I think I've asked it of everybody so far. What was your? Well, I guess talk me into how did you meet Goon and ultimately come to work with Goon at Cornell?
Yeah. So I guess that goes back to how I stumbled into crypto.
Yeah, let's hear that story.
It was my junior year of school. My dad actually was the one who had gotten into Bitcoin and Ethereum first and doesn't have a technical background, but understood it enough to understand its benefits and understand that it is very interesting technically.
That's so cool. That's so cool.
And so he kind of offered it up to me as like, hey, like, I don't know how this works, but it seems like it's something that you would know how it works. And it seems like a really cool field that's just starting. So yeah, it's my dad who originally kind of pointed it out to me. So then I was researching a bit to try to see if I could understand how Bitcoin worked. And of course, then every other paper I was reading at that point was by some guy named Emin Goon Searer, and I was like, okay. Then I Google him, it's like, oh, okay, so he's at Cornell, so that's a good start. Nice. And then I checked the next semester, I was taking operating systems, and he was in line to be the professor for my OS course. So OS was the first time that I met Goon. That was a really interesting experience because it was probably a 350 person lecture
Wow.
since it's part of the core curriculum. So it's in this huge lecture hall. The first day, Goon makes it clear, no laptops open during class,
Wow.
no phones out, and like he just like asked that point blank of everyone, was like, this is what I'm expecting of you. Here's what you can expect of me.
Sure.
And of course, a lot of professors ask that, and then it kind of tails off. But the second lecture, someone maybe missed the first one, or I'm not sure, but someone had their laptop open close to the back of this big auditorium. And I wish I remembered their name, but I don't remember their name. But Goon called them out by name. It was like, hey, put your laptop away. And by their first name, I don't remember what it is now, but everyone was just shocked that he knew this person's name. I'm not sure if he planted someone there or what, but he definitely commanded everyone's attention very quickly at the start of that semester.
So go ahead.
I was going to say he ended up learning most of the people's names in the class just from interacting, which was, I remember that it was particularly impressive in such a big lecture.
Sure. Yeah. Goon has, like, my perception of Goon is that he has one of the most laser sharp intellects of anybody that I have personally worked with in my career. He is absolutely, you can tell he's been a professor at an Ivy League school for a long time, because he's able just to cut through any hand waving or any bull crap and immediately cut right to the heart of whatever you're trying to say or trying to hand wave. He's able to see right through the truth of what you're actually trying to say. So I've asked Stephen and asked Stan and asked Connor, what was your blink instinct, or your blink intuition or impression of Goon, like with your very first time you met him?
Yeah, I think the very first time, or maybe second time, I guess, that I met him would be the one I just described. There was that he clearly had full command of exactly what he was teaching, but also super ready to engage anybody coming in with an open mind, no matter where your knowledge level was at, and was able to explain things in such a way that you understood, and he would make sure that you understood, no matter what knowledge level you were coming in at. And he really kind of commanded the respect of everyone in the room that second day when he called someone out in the back row for having their laptop out during class. And it's kind of, he's always lived up to that in terms of when he's talking, you want to be listening. And when you're talking, you can tell that he's listening to you. And
yeah, absolutely.
It's very much a circular feedback loop there.
And how did you end up getting involved in, blockchain and Ava Labs?
Yeah, great question. So it was at the end of OS then, the fall, the end of that semester, right before winter break. And the course had just wrapped up, and Goon recommended I think it was in office hours actually. He's like, oh, I forgot to mention in class, I'm starting this blockchain course. If anyone's interested, it's going to be really cool. It's graduate level course.
Nice.
I don't have the curriculum down yet, but we're just going to read papers and talk about them and see like how much of the space we can cover throughout the spring semester. And that was enough for me to immediately sign up for that.
This year, you're saying this was when, 2016, or what year was this?
2018, is spring 2018 then. And it was actually the first time that blockchain course was offered at Cornell. So Goon was teaching it, and there was really no set curriculum other than the papers he would choose for each class.
Got it. So 2018 was around the time that the Avalanche Whitepaper dropped. Is that correct? The Team Rocket?
Yep, exactly. Which was, in retrospect, really interesting because he was teaching the blockchain course in the spring. And many times he'd be like running into lecture, or I guess it wasn't a lecture, it's more of a discussion at that point, but running into the class a couple minutes late, clearly out of breath, and like clearly was doing a million things at once, and didn't mention specifically, he alluded to that he was working on something cool that hadn't been published yet, but didn't say anything more than that. So I guess that's when he was communicating with Team Rocket. And then it was the day after the final presentations for that course when the Avalanche paper dropped.
The day after?
The day after, yeah.
Amazing.
Which of course then like everyone put it together. It's like, oh, this is what he was involved with.
Sure. What did you do for your final?
I was actually working on an SGX related project. So we haven't talked about SGX yet, but that's the Intel technology that we use to develop the new Avalanche bridge. And I was working on a project building out a prototype exchange using Intel SGX. And that's kind of when we first were piecing together how you could leverage SGX within the crypto space, within the blockchain space, to get some really unique properties.
Sure. And so how did you get introduced to SGX, and what made you resonate with it so much that you ultimately did your senior project on that, or your final project, I should say?
Yeah, so the first time I heard about it was in the paper called Town Crier, I believe, which is a paper about on-chain data feeds, authenticated on-chain data feeds, kind of what Chainlink is serving as today, although Chainlink, I don't believe, uses SGX. But people at Cornell were involved in writing Town Crier, and it basically outlined a way where you could get verified real-world data onto Ethereum using SGX.
Did they call it oracles at the time or no?
Did they call it what? Sorry.
Was it already considered oracles? Was that term being thrown around?
Yeah, I think they did call some portion of the system was called an oracle. Yeah. And there was also a few other SGX papers. Tesseract, I think, is one that outlined architecture where you could build an exchange using SGX, a crypto exchange using SGX. So no one had really implemented it yet, so that was where we kind of picked it up with the project for that course.
Got it. And so, so then you've been working with SGX now for, I guess it sounds like 3 or 4 years at least?
Not quite. So I worked on it. I used it anyway in that course in spring 2018, and then picked it up again when I joined Ava Labs, and that was in September of 2019. So there's a little over 1.5 years there when I was working in Boston for DraftKings.
Got it. And what were you doing there?
I was on their identity team. So it managed KYC, identity verification, geolocation, basically all of their compliance software. I was a member of that team, which was a really cool, great learning opportunity. They have a huge user base, obviously, and I'm a huge football fan. So it was a perfect first job, I'd say.
What tech stack?
They mostly use .NET services, so C#, AWS. Yep.
And do you like the Windows stack, or do you like more like the Linux type stack?
I find that I like whatever I end up using, which isn't a bad thing, but maybe I haven't exposed myself to all of them enough. At the time, I feel like DraftKings had figured out how to build out that stack really nicely, and had reached the level of maturity as a company where they had good developer tools and onboarding materials, and everything like that. But now that I've been working in C++ for almost 2 years now, and Golang, I think both of those are also very, very good languages. So.
Yeah, I'm spacing on his last name, but if I remember correctly, the creator of C# and .NET, isn't his name Anders something?
I think so. Microsoft.
Yeah, I believe he's the same guy who led the team which created TypeScript, if I remember correctly, how that all played out.
That sounds correct. Yep.
Yeah, and it's interesting to me, just as a sort of a side note. So whenever I first started doing web development, it was probably around 2010, 2011. And at the time, Microsoft was notoriously hated across the entire sort of web space because of the ways Netscape Navigator ultimately fought against Internet Explorer, and the Netscape Navigator got acquired by AOL, I believe. Is that correct? I think Netscape ended up at AOL, and then Internet Explorer ended up having like 99% of the market share. So the very first job I ever had right out of college was building a internal website for Walmart. So I was doing like contracting work, building a big internal kind of like portal for Walmart employees. And I guess because the Walmart had signed like a multi-year big money deal with Microsoft to where all of the project managers had to have a certain laptop, and we had to target Internet Explorer 6. And so Internet Explorer 6 may be before your time, but anybody out there who's a web developer who was around at that time knows that Internet Explorer 6 was notorious for being like this absolute kludge. And a lot of people consider that it sort of held back the web for a long time. And there was this really nightmare scenario where you had to create like one version of your website that worked on standards compliant type browsers like Firefox and emerging Safari, and then you would have to create another one that had all of these IE APIs. And it's interesting to me that, considering the way I viewed Microsoft whenever I first started my career to the way I view them now, they really have done a full, sort of like they've switched their game up completely to where now they help drive the HTML5 standards body. The Edge browser and the latest versions of Internet Explorer have like super, super good standards compliance. They released TypeScript, which to me is absolutely critical. If you're a JavaScript developer, you should be a TypeScript developer. I've been saying this for years. I've worked with full-time with TypeScript now for about 3.5 years. It's such a big leap forward. Perhaps you don't appreciate it, although maybe you have some Python experience, but like I approach programming from a different angle than yourself, right? You've done a lot of C# and a lot of super powerful languages. Myself, I started out doing like straight up web development. So HTML, CSS, even jQuery, even before I got to JavaScript, right? So I started at a very, very high level. And so again, this may be super obvious to you because of the direction you came from, but having worked with a big chunk of my career with no types, like straight up using JavaScript to using TypeScript, it is such a radical leap forward. And it's been a universal experience of mine. Every single time you port a JavaScript app to a TypeScript app, you will find bugs, simply because the language is so fluent that it'll cast a string to a number and you won't even be aware of it, that you've got that bug in your code. But JavaScript does the right thing for you in most cases. And so again, to kind of steer back to what I was saying, Microsoft has improved their game so much that today, like nearly all of the tools I use in my day-to-day workflow, from VS Code to TypeScript, are all emerging from Microsoft. And to me, that's just very, very interesting. And so I kind of wanted to give a shout out there. So whenever you...
And just to add on to that, actually, also Azure is quickly caught on as well. We use that for their SGX integrations. So let's go down that rabbit hole a little bit. So to me, I kind of think of there's like 3 clouds that I myself have played around with. I've played around with Azure, I've played around with AWS, and I've played around with G Cloud. What are your thoughts in that space? Do you have a preference? Could you just give or take all 3? Are they replaceable? Is there something that absolutely rules about one that you can't replace? What do you think about those clouds? So I don't have any experience with Google Cloud, but I will say that both AWS and Azure seem to always fit my needs, which admittedly are pretty limited for any side projects that I'm doing. So I think they both have their, I think Azure is particularly good for launching SGX applications right now. AWS has their Nitro support, which is also in the trusted execution environment zone. But we were specifically looking for SGX support, which Azure offered us. So beyond that, I think they probably have most of the similar capabilities. It's just a matter of what you're comfortable with and how easy it is to get exactly what you're looking for set up, tuned correctly, and of course, secured.
Sure. Yeah, it's definitely, there's feature parity, but then you kind of come to just you feel at home and speak a certain language. You become you become idiomatic. So I'm wondering, like, what about Azure and SGX? Is there some special sauce there that makes the support there better? Did Intel focus on it earlier? Like, why is SGX and Azure?
It's just what Azure decided to offer. So SGX, you need the actual chip on the machine, so it's more difficult to virtualize in terms of having virtual machines on within data centers. So it's definitely more strict criteria for hardware that you're looking to run your applications on. And AWS, I think, is putting together their own solution that I actually haven't had time to play around with yet, but Azure had the out-of-the-box SGX support.
Yeah, so can you tell us about SGX? What exactly is SGX? How does it work? And what are your thoughts on it?
Yeah, so SGX is trusted execution environment that Intel has put together. And it's really, I think, technology that hasn't quite caught on yet in terms of its broader use. You're able to run a program within an SGX enclave, and other people can attest that you ran that version of a specific version of the program correctly within a tamper-proof enclave. So really allowing this remote attestation is the most powerful aspect of SGX, that someone not at the machine that's running the code is able to verify that the code is running correctly on that machine, down to the hardware level. And it also has a lot of great primitives in terms of encryption and such, where you can get really nice privacy properties out of it.
So how does the remote attestation work exactly?
Probably
super high level, whatever you can.
It's mostly just a cryptographic protocol back and forth. There are a couple different versions of it. One relies on the Intel attestation service, so you do have to rely on trusting Intel that they attested to the enclave and that they actually recognize the serial number of that enclave. And then there's DCAP, which is data center attestation primitives, where you actually get to take Intel out of that loop. So that's kind of the next generation. But you get, so there's a Diffie-Hellman key exchange as part of the attestation protocol, which, for those not familiar, basically me and Gabriel perform a Diffie-Hellman key exchange, and as a result, we have an end-to-end encrypted channel that no one else is able to see. And then you're able to exchange secrets in such a way, and the enclave is able to sign messages in such a way that you can get cryptographic proof that the enclave is running that exact version of the code identified by its hash, and that it's a valid enclave, of course.
Got it. So were you, I don't remember, I know that our original AE bridge was built on ChainSafe's chain bridge technology. Were you involved with that project, or were you hands off?
No, I was not, actually. I wasn't involved in that at all until the very end when we were migrating it over to our new bridge.
Got it.
But a lot of the AEB foundation was within smart contracts on Ethereum and on Avalanche, and then it relied on the relayers as, I believe, a 305 relayers in a multi-sig on the smart contracts. It's not an exact corollary, but it's close enough to think of the enclave then as including a lot of that smart contract code, which then makes it much faster and it's much less expensive to run code within a single enclave than it is to run to invoke a smart contract. Because to invoke a smart contract, you need to send a transaction on the Ethereum or Avalanche blockchain. That transaction needs to get included within the blockchain, and then all of the nodes in that network replicate that execution, which is a super powerful concept in terms of decentralization and trustlessness. But on the exact opposite side, instead of running that code on every node in the network, over 1,000 nodes on Avalanche right now, you can imagine every single one of them would have to perform that same exact computation. or you can do it once inside a single SGX enclave, and that enclave can produce a report that it actually did the computation correctly.
Wow.
So it's definitely very different properties, but they kind of get at the same aspect of you're able to verify that your code ran correctly. So instead of doing this multi-sig on chain for the AEB bridge, the multi-sig, and it's not actually a multi-sig, it's a Shamir secret sharing scheme. But 3 out of 4 of the AB wardens have to approve a transaction in order for the enclave to sign it, instead of 3 of 5 AEB relayers sending a transaction on chain. So each of those transactions has their own confirmation time, has their own transaction fees, which add up very quickly. And we kind of were able to cut a lot of that latency and a lot of that cost out by putting that computation within an enclave.
And so that's why we say the new AB or the new AB bridge is so much cheaper or more inexpensive, maybe is a better way to say it, the AEB bridge, specifically what you're saying, right? Instead of having to run all of these smart contract calls, we're instead doing it in this enclave. Is that the high level? Okay.
Yep.
Got it. And so how long have you been working on the AB?
So we first, I guess it's kind of a tiered question. We first tried to build a SGX bridge last fall, but we built it to the X chain instead of the C chain. So that's the Avalanche virtual machine instead of the EVM. And we actually got that deployed and it was working. But at the time, and still today, the X chain is really payments focused. And most of the DeFi world today exists on the EVM in terms of being able to use these assets within smart contracts, within dApps. And that's when we really kind of went back to the drawing board and said, okay, this X-chain bridge is cool. It's great at what it does, but we want something that's able to have tokens live on the C chain and interact with all of these smart contracts. And so we went back to the drawing board and really came up with the design in April of this year. It was Easter Sunday, actually, when we finally put some of the pieces together, designed it so that there's no public facing API, that the only interactions from a user perspective are sending one simple transfer transaction on Ethereum, and then it kind of goes through the bridge and pops out on Avalanche, and vice versa. So we started development, I'd say mid to late April, and have been working on it since then. So it's definitely a rush to get the initial version in place and then to get it audited and fully tested. And then we launched at the end of July there. There's a few weeks where it's like, okay, maybe next week, maybe next week. I've been on projects, so it's the same where you're getting close to the finish line and you think you can push just a few more days to get there, but it's kind of elusive. But we finally were able to get it out at the end of July.
So then if you, how long did you spend on the AVM version of it?
That I don't really remember, probably a month, maybe 2 months. We were working on it kind of in the background while we were also working on other projects at the time. There's also a lot of overhead in actually making it trustless. We never actually were able to take those steps to make the X-chain version fully trustless deployment. So I guess we haven't really talked about the AB architecture, but it relies on these warden nodes, where 3 out of 4 wardens have to approve a transaction in order for it to be processed. And it turns out to have a lot of overhead actually getting independent third-party wardens. So we have Fulgur, we have Avascan, Beware, and Halborn, the security audit company. And those companies are each running one warden node for us, and getting them set up and up to speed and coordinating to actually do the launch was very exciting, but also took a lot of coordination.
And so these are akin to the relayers at a super high level?
That's right.
And then the overhead is why you said there's a lot of overhead there. Why? Just getting people to take on the responsibility, or what exactly is the issue?
Yeah, just business and human overhead in terms of getting partnerships in place, like approaching those companies, pitching the project, like this is why you want to be a part of this bridge with us, and really building out that relationship to the point where they are willing to devote resources to the technical aspect of running a Warden and getting that all set up. So communicating with those, great partners. They have been spectacular to work with. There's just human overhead and kind of pitching and selling the idea to get everyone on board. And it's new technology, so I think it's always the first few steps of getting traction on a new technology is always a bit challenging.
Sure. And so just to give some context there, in the beginning, there was a huge focus on having all of the integration points with the Avalanche ecosystem and exchanges, for example, to be on the X chain, because the X chain, as he mentioned, is a DAG, and it's for peer-to-peer payments. When the C chain is a linear chain that has total ordering, it's really good for smart contracts. And so initially there was like a business development push to have all of the exchange integration happening with the X chain, because that's where Avox, the asset, was issued, and it just made more sense in the beginning because we were trying to get Avox to plant that seed and get it to grow. And then it seems like very shortly after that, I think the company came to a realization just how much energy was in the EVM and the C chain. And so since then, there's been a big biz dev shift to now have everybody sort of focus on the integration points being on the C chain as opposed to the X chain or the AVM. And so that's why I kind of asked about, how long did you guys spend on the AVM? And one of the questions I got from multiple people, let me see if I can find it real quick, is I guess like what is to tie it in with, you spent some time on the AVM and then ultimately you shifted to the EVM. And this is no longer called the Avalanche Ethereum bridge. The original bridge, which was a lock mint bridge with relayers, and it was based on ChainSafe's chain bridge technology. Please correct me if I said that wrong. It was called the AEB, the Avalanche Ethereum Bridge. And from what I understand, the new one is called the Avalanche Bridge. And so clearly we removed the word Ethereum from there. And so one of the questions, and obviously feel free to skip it if you're just not able to answer it because of biz dev reasons, or it's not public or whatever, but what does interoperability look like in the future for these bridges? How hard will it be to refactor the work you've done now to bridge to the AVM or to bridge to any one of these other layer one blockchains out there?
Yeah, absolutely. So it depends, I guess, is the short answer.
Sure.
I think we designed the bridge initially now to be able to easily integrate with any number of EVM chains, be it BSC, Polygon, and the like.
Okay.
We don't have any hard dates on when we would add support for additional networks or what those networks might be, but that's certainly a possibility in the future. But the SGX component of it is in C++. It's not tied to any virtual machine in terms of the AVM or the EVM. We can really, we have the flexibility to build in new support for new VMs within the Avalanche bridge. And I think that's something that's very powerful as well. We've talked about, we've kind of sketched out how we could potentially add native Bitcoin support and bring Bitcoin over to Avalanche, and how that could work, whether it live on the X chain or the C chain or on its own subnet. And, there's really, within Avalanche, there's so many possibilities for interoperability, and so many possibilities for really uniquely tailored applications. And we wanted to kind of mirror that within the bridge in terms of the future directions that we could go. In terms of what I think interoperability will look like down the road, really whatever we make it to be, I think, is the answer, because there's just so many possibilities.
Sure.
And I think interoperability is a really hot topic right now, with a bunch of bridges coming out. People see the possibilities of things they can do with their assets on a single network, and then I think a natural step is, okay, what can I do on other networks?
Sure.
Like, I have these crypto assets, and I don't want them to just be on Ethereum. If I want to take advantage of DeFi on Avalanche, or move over to Matic, or whatever you'd like to do. But on some level, I don't think it's entirely necessary. So the virtual machines kind of are what they are right now. I think they'll probably change going forward. But I don't think we need a purely interoperable world where you can have a dApp deployed across multiple networks and you have seamless interaction between those networks. It's more so, I think of it like the virtual machines are akin to, or the networks actually are akin to operating systems, where I don't need all of my applications on Windows to interact flawlessly with my applications that I run on Ubuntu or run on Mac OS. But what you do need is to be able to export a file from those applications that you can use on other operating systems. So, you want to be able to move your assets from Ethereum to Avalanche to Matic, and you want to be able to leverage what each chain is good at and what the best offerings are for. But I think a lot of the general interoperability is a really cool problem, but not something that we strictly need right now.
Sure. And so how did you, kind of jumping back and forth a little bit, but how did you first find out about the Avalanche platform? I guess presumably you said at the end of that one semester you saw that there was a white paper, and then you approached, I guess, in 2019 to join the team. Were you aware of the progress that was happening while you were at your other gig? Yeah,
I was definitely following along. They had, I think it was May 2019 when there's the first private testnet. So I definitely was tuned in when they made that announcement. And then it was June of 2019 when Goon actually pinged the members of my project that I had worked on for his blockchain course, asking if we could add him to the GitHub, because he was doing a hackathon at Cornell for a weekend and wanted to keep working on it. And so I, of course, added him to the GitHub and asked if there was anything I could do to help. Like, let me know. I would certainly be happy to assist. And he's like, well, how about you come join my company?
No way.
Yeah, that was a pretty cool email to receive from Goon. So I then interviewed after that and joined in August of 2019. I interviewed in August and joined in September of 2020.
Got it.
Sorry, 2019. Getting all these years confused now.
Yeah, it's all good. So then whenever you came on board, did you immediately started working on the bridge?
Not quite. I was immediately kind of working within SGX and some different projects that still haven't been fully announced yet. So we won't go into that too much, but definitely exploring the possibilities of leveraging SGX within the blockchain space from the start, and also assisting where I could with the platform, sitting next to, back when we had an office pre-COVID in Williamsburg. It was the early days, sitting next to Dan and Stephen. So yeah, it's been a quite a ride so far.
And how big was the team that built the bridge?
So the team that built the bridge was, well, I don't want to leave into it now. There's probably 12 people in total. So the back-end team was mostly myself, Bernard Wong, who's a professor at the University of Waterloo. Connor Leary was another huge contributor on the back end. Gergely worked on the front end. We obviously had a ton of DevOps support, ton of biz dev support, marketing. It was a kind of whole organizational effort that we kind of owned as a team from start to finish.
And how much of it is smart contract driven?
That's an interesting question. I'd say probably, as far as bridges go, very little of it is within smart contracts in terms of actual deployed smart contracts on an EVM chain. So the smart contracts are limited to the wrapped token contracts that live on RC chain. So right now, there's no smart contracts on Ethereum. The enclave itself acts as a smart contract in some sort of way. I kind of use that analogy pretty frequently. It's an off-chain smart contract. You interact with it by sending a transaction on Ethereum. And by sending a transaction on Ethereum, you invoke the enclave code. And then the enclave interacts with the smart contract on Avalanche. So in that sense, I think it's a cross-chain smart contract. But the actual on-chain smart contracts are limited to ERC20 implementations on the C chain.
Got it. And so then could you give me like a pros and a con for a Warden sort of SGX type setup versus a lock mint relayer kind of, like if you had to sell me on both of them, can you give me pros and cons for both?
Yeah, absolutely. So just to be clear, we're actually also a lock and mint architecture.
Okay.
So the enclave is locking the funds on Ethereum and minting them on Avalanche. And then you unwrap the fund. When you unwrap the funds, they are burned on the C chain and then released on Ethereum. So that type of architecture is, or that type of paradigm is very similar between our new bridge and the Avalanche Ethereum bridge that existed previously. The pros of the AB, I think, are that it's easier to use. It's slightly so I guess from the participation standpoint of a relayer versus a warden, the wardens have much lower overhead because they don't need to send transactions on chain. So as part of the AEB, each relayer would need to contribute to the multi-sig that was happening on Ethereum and on Avalanche by actually sending those transactions and having them be included in the blocks. And that created, a lot of cost for the relayers because they were sending transactions, and that's not cheap on Ethereum. And I mean, there's dynamic fees coming up on Avalanche, but they also incur Avax transaction fees for sure. Two, it creates a lot of delay because you don't know how fast those transactions are going to be confirmed. There could be a spike in gas prices. And it just generally kind of slows the process down, waiting for those confirmations. And in contrast, so that's the AEB relayer. In contrast, the Warden for the new Avalanche bridge is only really monitoring each network and sending its approvals to the enclave over an encrypted channel, but not sending any on-chain transactions. So it's much lower overhead in terms of speed and in terms of cost to be a Warden rather than to be an AEB relayer. And having the enclave really coordinate between the wardens allowed for us to speed up that process as well.
Got it. And so are there, what is the sweet spot with regards to the number of wardens and the MMN, or however you would want to phrase it? What is the sweet spot?
That's a good question. I don't know. It's really a little bit open-ended there in terms of security risks, in terms of, I mean, yeah, really it just comes down to security. On one hand, the more the better. If you had a 90 out of 100 multi-sig, I think that would be great because very unlikely that 90 parties would collude. But that also creates a lot of overhead in terms of getting 90 approvals for every transaction. Even in our new setup, that'd be a lot of communication overhead, even though you're not having transactions on chain for each approval. The current state is 3 or 4. I think ideally in the future we could hopefully get more wardens in there. I think maybe 7 of 10 could be a sweet spot. But yeah, it's an interesting question there in terms of like, ideally, it would kind of anyone would be able to be a warden. So you could participate in these cross-chain transactions in an open, decentralized network. But that creates so much overhead that it's really inhibits the feasibility and the usability and the cost of those bridges. So I think, yeah, if I had to like have my pick, I'd say 7 of 10 is probably a pretty good sweet spot. But I'm definitely open to hearing other people's arguments there as well.
Sure, because then you've obviously got to find the organizations, which is just as challenging as the code, really, is just the social aspect of everything, simply because there's not really a ton of super competent people in the, how can I say that? There's plenty of competent people, but the blockchain space in general is just understaffed. It's still one of those, it's
definitely understaffed.
Yeah, despite the fact that it's not nascent. I wouldn't call the technology nascent anymore. It's clearly mature, and there's we're 10 years deep into the revolution, but it's still just so much opportunity for people in this space because there's just so much going on. Things are moving so fast. There's so much money on the line and so many stakeholders, and the potential to have an impact with your work. I always say, if you're looking for a place where you can have an oversized impact with your work, right? Like there's 1,000 different things you can work on, and in some of them you're not going to make a difference at all, and then in some of them you can just have a crazy radical impact. And to me, the blockchain space still, despite it being 10 years old, which is a long time in the field of innovative technology, right? Like Moore's law is kind of like the label that we apply to everything, but obviously Moore's law is very specific about integrated circuits on transistors, but it's kind of like a catch-all phrase that we just throw out there for the pace of change is accelerating and computing price performance is doubling every so many months or whatever. But there's 1,000 different Moore's law type scenarios or phenomenon that apply to many different fields of study in computer science other than integrated circuits. But we say Moore's law. So the reason I mention that is, if you think about 10 years with regards to Moore's law, I believe when Gordon Moore first put the dots on the page, I think it was 18 months originally was Moore's law. But Ray Kurzweil, who I'm a big fan of, the guy who wrote The Singularity is Near and The Age of Intelligent Machines and The Age of Spiritual Machines and Live Long Enough to Live Forever, he's like, I think one of only 6 civilians on the Army Science Advisory Board. I believe he has literally 17 honorary doctorates, which I'm sure most of those are just, institutions congratulating him. But he's one of the main engineers at Google. And he points out in his book, The Singularity is Near, that the price performance doubling that was originally 18 months as defined by Gordon Moore at Intel is now like 11 months. So, the pace of change is accelerating. And so if you think about it in that regard, 10 years is like 10 turns of the screw with regards to Moore's law or this, doubling of technology. And so when you think about it in that way, the blockchain is really kind of old, right? If you think about 10 years, so the way I think about it is like the iPhone came out in 2008 or 2009, I believe, Android as well, and so did Bitcoin, right? So they both sort of came out at the same time. And if you think about which one of them had a bigger impact on the world, I would say it's mobile, right? Because every single person in the world has a mobile device now. And, we've all, if you think about all of the extra phones we've got around and all of the different iPads, we've all got like 10 computers or something like that in our lives. And the blockchain technology has not really had an impact on the same way. Obviously, that's kind of a rough analogy. There are 2 different technology stacks, but I mentioned it simply to sort of come back to my original thought, and that is, the blockchain is now 10 or 11 years old, and there's been all of this progress, both directly in the blockchain space and then in, just computer science in general. But there's still a huge amount of opportunity in this space because despite the fact that it's been 10 years, it's still incredibly hard to find super competent people. Whenever you were at Cornell, were you involved in the Blockchain Society or any of the social movement?
No, I wasn't actually. I wish I was. I think those are also just getting started around that same time. But did not participate in that during undergrad. But yeah, absolutely. It's been very interesting to see like just the past 2 years worth of growth within the space. I think Moore's law definitely applies. Maybe different exponents or coefficients. Or I'm not sure all the details there, but it's yeah, I think crypto is kind of old in that aspect, but at the same time, I think we also have had the rate of development and the rate of innovation, I think, has kind of kept pace. Maybe the adoption isn't quite there, but I'm hopeful it's in the future still. So there's a ton of possibilities, and yeah, as you said, like there's so much to do that you can have that oversized impact, but then it also makes it really difficult to find people to work with, because everyone kind of has their own passion within the space or their own project that they're working on, and everyone's kind of overcommitted already. So,
boy, that's for sure. Yeah, one of the things. So I've been in the blockchain space now. I've got my first Bitcoin in 2011. So I feel like a super OG, right? I've seen a bunch of different phases of the Bitcoin world. In 2014, around the time Ethereum was being fleshed out, I had a vision for a startup called Gitcoin, which of course now there's a hugely successful project called Gitcoin. But at the time I wanted to do developer services for Bitcoin, because already at the time I sort of understood like there's ultimately going to be SDKs, there's ultimately going to be cloud services. It's like the same infrastructure that exists for any other kind of successful tech stack is going to ultimately emerge in the Bitcoin space. And then of course I was fortunate enough to experience like the Ethereum crowd sale. And then I was also there for the scaling debate of Bitcoin and Bitcoin Cash. And I was a big advocate of Bitcoin Cash, and I had a Bitcoin Cash startup that got acquired by Bitcoin.com. And having gone through all of that, to me, it seems like overnight the blockchain went mainstream. So, in the past year, like I would say, compared to what I've witnessed over the past 10 years, to me, the blockchain has gone mainstream. And the analogy I've used many, many times, so if you've heard it and it sounds tired, I apologize, but it does, it's how I feel about it, is whenever the web was first born, in the mid to late 90s, the computer scientists, the hackers, the academics, the entrepreneurs, the people who worked in the industry appreciated that the web was going to be have a radical impact on society, right? So as soon as the web was launched, there were people who were like, oh, wow, this is going to be crazy huge. And so a bunch of money rushed into the web, and we had the dot-com boom because a lot of people knew that it was going to change everything. But as people started playing around with the technology, they realized that, hey, you know what? I don't think this technology is totally mature. It's certainly like the user experience of using a website in 1998 is not as good as using a native app in 1998, right? If you're using a Macintosh or Windows, the native app is much more powerful. And so a lot of the money rushed out of the web, and the dot-com bubble popped, of course, notoriously in 2000, 2001. But the people who saw the vision continued to work very hard. And then around 2004, 2005, there was this coming of age moment when AJAX emerged in Web 2.0. AJAX stands for asynchronous JavaScript and XML. And from the Web 2.0 movement, we ended up getting, Facebook and Twitter and Flickr and the beginnings of the HTML5 movement and modern CSS. And so all of the web that we think about today, the web evolving from like a document and scientific type platform that emerged from CERN, famously Tim Berners-Lee was a physicist, or he was a computer scientist working at CERN, which is the big atom smasher in Switzerland. And originally the web was just a place for scientists to share documents. Tim Berners-Lee actually pushed back on the idea of an image tag in the very beginning. They very, very much did not perceive it as being like an application platform, but it ultimately became an application platform. And a big part of that was this coming of age moment with Ajax and Web 2.0. And to me, that's what Avalanche Consensus feels like to me. Now, granted, there's plenty of other exciting blockchain projects, but Avalanche Consensus is a very, very significant milestone. And the reason being that, similar to the web, people have known from the very beginning that the blockchain and the blockchain technology stack had the potential to be incredibly transformative. But we ran into this wall of Nakamoto consensus just not kind of being mature enough to do this entire class of use cases, such as point of sale, right? So, you want to go in and famously buy a coffee with crypto. Well, Bitcoin had something called zero confirmation, which was removed whenever the Bitcoin core developers added replaced by fee, but it was returned on in Bitcoin Cash. So there are flavors of Bitcoin where you can effectively make a transaction and it settles, if you will, nearly instantly. So, you could buy your coffee and leave, but that doesn't exist in the main Bitcoin, BTC world, for what it's worth. And even Ethereum, with its relatively fast blocks, 15 or 20-second blocks, even that boxes you out of a whole set of application opportunities. So, for example, like traditional finance exchanges, these different firms will actually put their hardware in different places around the world simply to get fractions of a second shaved off of different web requests, because it gives them such a competitive advantage. And so when you're dealing with something like Ethereum, where the blocks are every 15 or 20 seconds, it's just not fast enough. But Avalanche Consensus, which gives you sub-second, completely immutable and irreversible finality, really just opens up the door for all of these use cases, from decentralized exchanges, which can compete with centralized exchange user experiences, all the way to like point of sale. So you can now use, crypto as peer-to-peer cash. So despite, there are a lot of exciting things happening in the blockchain, and there have been for a while, but to me, Avalanche Consensus really does represent this coming of age moment, similar to Ajax with the web, which ultimately enabled Web 2.0 with Flickr and Facebook and Twitter and HTML5 and CSS and the modern version of JavaScript. All of those things emerged once the web matured and had a coming of age moment. And to me, it feels like we're undergoing that right now with the blockchain. And that's why I say in the past year, really, the blockchain went mainstream. So we had things like huge thought leaders like Elon Musk entering the space. And so the reason I think that Elon Musk entering the space is very significant is because, to me, Elon is like the current Steve Jobs. And by that, I mean, he is the person who the zeitgeist, like the way the society is sort of viewing things, he has filled that role of Steve Jobs, where he can come in and he can sort of bless a technology, and the mom and pop investor of the world are going to kind of automatically be turned on to that technology simply because Elon Musk has so much social clout that he can come in and say, hey, Dogecoin is going to be huge. And all of a sudden, Dogecoin is in the minds of all of these investors around the world.
For better or for worse, of course. But
yeah, for better or worse. And to me, I feel like what I suspect will happen is what happens to most people who enter the blockchain space. Everybody kind of goes through the same sort of life cycle and evolution, where you show up and you realize peer-to-peer payments is very transformative. So being able to send any amount of money to anybody, anywhere in the world, no borders, basically free, basically instant, is incredibly, incredibly powerful. And if you've ever tried to move money internationally, you know what a nightmare all that is. But then immediately you sort of hit the wall of peer-to-peer payments is cool, but you know what else is cool is tokens are cool. And you know what else is cool is smart contracts are cool. And all this other stuff that Ethereum is offering is very cool. And you don't really get that stuff out of the box. Go ahead if you want to, if you have.
Yeah, I was just gonna say, I think that the coolest thing is going to be when people are doing, using blockchain applications where they don't even know that they're using blockchain applications. I think that's that I totally agree with the progression. Mm-hmm. You're like, first you do payments, and it's like, wow, that's kind of cool. Like I can send money with no intermediary and mm-hmm. with all the properties you just described, and then all the DeFi applications that exist today, and now NFTs and NFT marketplaces. Mm-hmm. And I think that's probably the first time where people, they probably know that they're still interacting with a blockchain or with crypto on some level, mm-hmm. But it's it's inching in the direction where Web3 is quickly just going to become the web.
Sure.
And I say inching because I feel like working at Ava Labs and on Avalanche, we're kind of on the front lines there. But when you take a step back, it's not inching. It's like full out sprint.
Yeah, it is.
It's going to happen. And I think when it reaches the point where Web3 is just the web, and where like you're interacting with an app on your phone, but you're also actually like interacting with the blockchain behind the scenes, and you don't even need to think about that it's a blockchain, or you don't even need to think about that your transaction needs to be confirmed, or where all of that is abstracted away. And I think that's the point that we're going to get to, and I think that will be the coolest point.
And that deserves a hat tip to Connor, who would be here tonight, but as I said, he's with his family. So
go buy some NFTs.
Yeah, exactly. The NFT marketplace that Connor, again, just gets such credit for. He did such a great job architecting that and being the lead to bring that across the finish line. It has been a slog, and he's been clocking them hours, so props to him. But one of the great things about that whole user experience is that Web3 stuff really is hidden away. And today, if you go and use something like OpenSea or any one of these other sort of popular NFT marketplaces, pardon me, the barrier to entry is relatively high. You know, getting crypto, going to Coinbase, doing KYC, buying some crypto, waiting for 2 weeks or whatever.
Not for long, though.
Yeah, and using MetaMask, knowing all that stuff, it's challenging. But using this new platform that was built, and it's one of the reasons that I really do believe that Avalanche is going to be the premier platform for launching licensed NFTs, is because of all the work we put in to build this system to where it abstracts it away, and you can show up and you can use your credit card instantly, and you can be buying and selling NFTs in a matter of minutes instead of a matter of weeks. You're right. Like, one of the reasons that the iPhone is so powerful is because you can give it to a little kid, and everybody's seen, 2-year-olds swiping and tapping. It's because the mechanics and the user experience are so natural and idiomatic to the way humans work that it's incredibly obvious. So despite the fact that touch screen is like 10,000 layers of abstraction above, all of the stuff that's happening behind it, from the cloud to security to everything, really speaks to the power of abstraction and user experience, and how that is the special sauce. The technology is great, but the user experience and the being able to abstract everything away is really where the special sauce is. And so I agree with you. Like, the most exciting part about the blockchain revolution is when it becomes no longer exciting, right? Whenever it's kind of just totally abstracted away. Yeah, got it. So let's talk about, like, what do you think in general about Ava Labs, man? What are some of the pros and the cons of stuff we've accomplished from the mainnet? Like, what is our biggest win, and what would you do differently if you could do it different?
Yeah, absolutely. And I do have to run here in a minute, but
yeah, of course,
happy to talk about Ava Labs. I think the biggest win, at least on the day-to-day, is the people that you get to interact with. I feel like we just have a lot of thought leaders and a lot of innovation going on within the company. And being within that environment always kind of pushes you to have new ideas and to bounce them, like perfect people to bounce them off. And just the daily interactions there are invaluable, I think, in terms of both making our offerings better, but also just innovating and advancing the blockchain tech as a whole. In terms of the biggest breakthroughs, I think it's definitely just has to be Avalanche Consensus. Don't want to put anything close to that level. And I think subnets are going to be what's the next huge phase that people may or may not see coming, but it's definitely coming. And once we get there, it's just going to be transformative, I think, in terms of the possibilities that it opens up for different organizations, different industries to leverage blockchain technology in a way that fits their needs exactly, but also interacts with all of the other portions of the network as they see fit. And that customizability and really that customizability and interoperability within the Avalanche subnets that will be created is going to be really exciting to see.
Got it. And so what do you think then about, same question, but to the blockchain space in general? What do you think are some of the pros and cons, and where do you think this is going to play out? Like, where do you see this 5 years, 10 years, 15 years down the line?
Oh, that's a difficult. Yeah, I mean, I think at the current rate of adoption, I think there's going to be so many applications that people haven't even thought of yet that will probably be the biggest ones. Like, we're probably in the MySpace days of social media on that scale. So trying to predict the next Facebook or the like is kind of difficult to do beforehand. But I think there's so much in the definitely, like, with the whole NFT space growing now, but also using NFTs as credentials or really real world objects. Like, why couldn't a car be an NFT? Why do I need to have a VIN number? Like, what is a VIN number even? I don't know.
Sure, you're right.
So I think there's like so many points, so many places where we can leverage this technology that we're currently building, but we just haven't gotten to it yet. What will actually be the killer app? I think that's anyone's best guess. Yeah.
Got it. Okay. So, and then what do you think about, you mentioned whenever you first discovered Bitcoin, did you read the white paper like early on? Is that how you got exposed to Bitcoin? You said your dad told you about it, right?
Yeah, my dad told me about Bitcoin. I think I read the white paper and had a rough understanding of it at the time, but then definitely reread the white paper for Goon's blockchain course. That was the first paper we read and went into depth on. So that was when I really kind of.
Did you appreciate that it was a significant document when you read it?
Definitely the second time there. Once we had the discussion with Goon and with everyone else in the class of like what specific aspects of the paper were so novel, that's when it really clicked, I think, to crack open the shell there and start digging in.
And what did you think of Satoshi, or what do you think of Satoshi?
I don't have much of an opinion on Satoshi, honestly. I think it's admirable that he's been actually able to maintain his anonymity, because, I mean, I just can't think of how that could even be possible. Like, if I tried to write a paper under a pseudonym and actually see it through and also not expose my identity at all, not only is it difficult from a personal point of view of like wanting to take credit for your work, it's difficult from a like operations point of view. And it's incredible,
especially because there's so many people. There's been so many people who've tried to find him.
Yeah,
They've
exactly.
Everything.
He did a very, very good job at not only creating the space, but keeping his identity unknown. And I think it makes for a really cool story that we'll be telling for many years to come, hopefully.
Do you think it was one person or a team?
I think one person. Definitely working with a few others at the time. I mean, similar to, I mean, I know Team Rocker was working with Goon and Kevin before they published that, and Ted, of course, before they published their paper. So I think some people probably had ins before the paper was dropped or before the first Bitcoin client was published. But I think it was one person.
Got it. Yeah, I've always to me, it's just interesting that nobody has came forward to even talk about code review or anything. You know, the code was not bulletproof. There was a minting bug in Bitcoin as well, but it was just really darn good. And to be pulled together by one person, obviously Satoshi would have been a polymath because he was able to touch on so many different skills. But just, you know, one person producing a code base like that is just so significant. And like you said, it's not human nature for someone not only to not take the credit, but then to also be sitting on, you know, however many billions of dollars that is today, an insane fortune, to have never touched anything, not one single time. He did some transactions, but there's all those blocks, those 50 Bitcoin reward blocks that are just sitting there, and to have never touched them is just not like what most humans would do, right?
Definitely not. I will say, have entertained the possibility that Satoshi's goon. And I feel like I know Goon well enough now that like I would have been able to crack him open, but yeah.
Sure. Like I have seen Goon on articles like who is Satoshi top 10. I've definitely seen him. Yeah.
He published a proof of work paper in 2003. Like he has all the credentials there.
Yes. So he created something called Karma. If you guys don't know, go Google it. Goon created the first proof of work type system called Karma in 2003. Yeah, you're right. 6 years before Satoshi created Bitcoin. So, you know, who was around solving those kind of problems that early on? Surely not that many people.
And then in terms of being able to write the academic paper, but also develop the code and then selfish mining paper. Yeah. So,
and the DAO hack.
But
yeah. Okay, man. Well, it's been an hour. Yeah, it's been an hour, and I want to be respectful of your time. It's Friday evenings, so I think we can call it. But I want to invite you back whenever we get a chance for Connor to come, because Connor had a ton of questions related to the bridge that would have been much more technical than we went tonight. And I know there's going to be a lot of people who are disappointed that we didn't get to deep dive with all the questions for Connor. So I just want to put out the invitation to you to come back again in the future, and we can have the conversation again.
Love to. Yeah, anytime.
Awesome. All right, Michael, thank you so much. Thank you, everybody, for watching. This is Gabriel Cardona. This has been another episode of the Subnet Show. We will catch you next week. Thanks, you guys.
Thanks, everyone.
Cheers.
See you, Gabriel.
Yeah. Cheers, man.